Good day, everyone. My report to tackle about is the Chapter 9 Introduction to Business Continuity. What is BC or Business Continuity? BC or Business Continuity is an integrated and enterprise-wide process that includes all activities that a business must perform to mitigate the impact of planned and unplanned downtime. BC entails preparing for, responding to, and recovering from a system outage that adversely affects business operations. It involves proactive measures such as business impact analysis, risk assessment, BC technology solutions deployment, and reactive measures such as disaster recovery and restart to invoke in the event of a failure. So, this business continuity is a process that helps business prepare for and deal with unexpected events that could disrupt their operations. This includes things like power outages, natural disasters, or cyber attacks that could cause downtime or prevent employees from working. The goal of business continuity is to minimize the impact of these disruptions by creating plans and procedures for responding to them. This process involves more than just IT-related activities. It encompasses all aspects of a business operations. For example, it might involve ensuring that employees have access to backup systems or alternate work locations in case their primary workspace becomes unusable. It might also involve developing communication plans so consumers or customers and stakeholders can be informed about any delays or changes in service. The purpose of this business continuity planning is to help organizations stay operational during times of crisis and recover quickly as possible after an event occurs. By taking steps ahead of time to anticipate potential problems and develop response strategies, business can reduce the negative impact on their bottom line and maintain customer trust even when they faced with adversity. So the goal of a BC solution is to ensure the information availability required to conduct vital business operations. So, what is information availability? Information availability refers to the ability of an IT infrastructure to function according to business expectations during its specified time of operation. Information availability ensures that people, includes employees, customers, suppliers, and partners, can increase or access information whenever they need it. Information availability is a term used to describe how well an IT infrastructure can work when it's supposed to. This means that the system should be able to function properly during its scheduled time of operation, so that people who need access to the information can get it whenever they need it. Basically, anyone who needs information from the system in order to do their job effectively. Information availability is important because if the system isn't working properly and people can't get the information they need, this could cause problems for everyone involved. So having a good information availability helps ensure things run smoothly and efficiently. So information availability can be defined in terms of accessibility, reliability, and timeliness of information. So first, accessibility. Information should be accessible at the right place at the right user. And then reliability. Information should be reliable and correct in all aspects. It is the same as what was stored and there is no alteration or corruption of to the information. The next is the timeliness, defines the exact moment on that time window during which information must be accessible. So, cost of information unavailability. Planned out stages. First is the planned out stages. Include installation, integration, maintenance of new hardware, software upgrades or patches, taking backups application and data restores. Facility operations includes renovation and construction and refresh or migration of the testing to the production environment. Then second is the all unplanned out stages include failure caused by human errors, database corruption, and failure of physical and virtual components. So these unplanned out stages is a situations where something goes wrong with the system or technology and it stops unexpectedly. There can be different reasons for this to happen. Nabilong ani ang human errors like someone accidentally deleting the important information, database corruption where the data stored in the computer system gets damaged or lost, failure of physical and virtual components like a server crashing or software not working properly. These kinds of issues can cause disruption and problems for business that rely on this system to function properly. Then, third is the natural or man-made disasters, such as a flood, fire, earthquake, and contamination. Then, consequences of downtime. Information unavailability or downtime results in loss of productivity, loss of revenue, poor financial performance, and damage to measuring information availability. One is the mean time between failure or MTBF. It is an average time available for a system or component to be perform its normal operations between failures. It is the measure of a system or component reliability and is usually expressed in hours. So this MTBF or mean time between failure, usa ni siya ka pamaagi to measure how reliable a system or component is. It calculates the average amount of time that a system can operate normally before it experiences any failures. This measurement is usually expressed in hours and it helps us understand how often we might expect a failure to occur. For example, if we have a computer system with an MTBF of 10,000 hours, this means that on average, the computer should be able to run for about 10,000 hours before experiencing any issues. Of course, this doesn't guarantee that the computer will last exactly 10,000 hours without failing. Some systems may fail sooner, while others may last longer. So this MTBF gives us an idea of how reliable a system or component is over time and can help us plan for maintenance or replacement when needed. So the second one is the mean time to repair or MTTR. Mean time to repair or MTTR, it is the average time required to repair a failed component. While calculating MTTR, it is assumed that the fault responsible for the failure is correctly identified and the required spares and personnel are available. So this MTTR is the average amount of time it takes to fix a broken part. When calculating MTTR, we assume that we know what we caused the problem and have all the necessary tools and people to fix it. A fault is a physical defect in one part that can cause information to be unavailable. The total time for fixing a problem includes detecting what went wrong, getting the maintenance team together, and figuring how to solve it, finding any parts needed for repairs, actually making those repairs, testing everything again, and then finally restoring data back to its original state. And then BC terminologies. Disaster recovery. This is the coordinated process of restoring systems, data, and the infrastructure required to support ongoing business operations after a disaster occurs. Then disaster recovery this disaster recovery is usa ni siya ka set of policies and procedures that focus on on protecting an organization from the effects of significant negative events and systems critical to supporting business operations after a disaster occurs. This process usually involves a separate physical site for restoring operations. The key aspect of disaster recovery is the ability to recover critical data and systems, which may involve restoring data from backups, setting up redundant servers, and switching over to this system. So, the next is disaster restart. This is a process of restarting business operations with mirrored consistent copies of data and applications. So, this disaster restart refers to the process of restarting operations after a significant disruption. It is more about getting the business operations running again quickly as possible, regardless of the underlying data and systems. This might involve moving to a new physical location, acquiring new hardware, or even starting from scratch with new data if necessary. The key aspect of disaster restart is the ability to restart operations, which may not necessarily involve the recovery of all data systems, but emphasizes on the continuity of business operations. Next is the recovery point objective. This is the point in time to which systems and data must be recovered after an outage. It defines the amount of data loss that a business can endure. Example of recovery point objective: RPO of 24 hours means backups are created at an off-site tape library every midnight. The corresponding recovery strategy is to ensure the data from the set of last backup tapes. Then RPO of 1 hour means shipping database logs to the remote site every hour. The corresponding recovery strategy is to recover the database to the point of the last log shipment. And then RPO in the order of minutes, mirroring data asynchronously to remote site. The next is the near zero RPO, mirroring data synchronously to a remote site. Then next, recovery time objective. The time within which systems and applications must be recovered after an outage. It defines the amount of downtime that a business can endure and survive. Some examples of RTOs and the recovery strategies to ensure data availability are listed. RTO of 72 hours means restore from tapes available at a cold site. Then RTO of 12 hours, restore from tapes available at a hot site. Then RTO of few hours, use of data vault at an hot site. Then RTO of a few seconds, cluster production servers with bidirectional mirroring, enabling the applicants to run at both sites simultaneously. So, data default means it is a repository at a remote site where data can be periodically or continuously copied, so that there is always a copy at another site. So another terminology is a hot site. It is a site where the enterprise's operation can be moved in the event of disaster. It is a site with the required hardware, operating system, application, and network support to perform business operations, where the equipment is available and running at all times. So next is the cold site. A site where an enterprise's operation can be moved in the event of disaster, with minimum IT infrastructure and environmental facilities in place but not activated. Another busy terminology is server clustering. It is a group of servers and other necessary resources coupled to operate as a single system. Clusters can ensure high availability and load balancing. So, business continuity planning life cycle has its five stages, namely establishing objectives, analyzing, designing and developing, implementing, training, testing, assessing, and maintaining. So first is the established objectives. So dinhi nga part is they need to determine BC requirements, estimate the scope and budget to achieve requirements, select a BC team that includes subject matter experts from all areas of the business, whether internal or external, and then create BC policies. Second is the analysis, wherein collection of information on data profiles, business processes, infrastructure support, dependence and frequency of using business infrastructure. Then conduct a business impact analysis and then identify critical business processes and assign recovery priorities. And lastly, perform risk analysis for critical functions and create mitigation strategies. Perform cost-benefit analysis for available solutions based on the mitigation strategy and evaluate options. Then third one is the design and develop. Define the team structure and assign individual roles and responsibilities. For example, different teams are formed for activities such as emergency response, damage assessment, and infrastructure and application recovery. Design data protection strategies, develop infrastructure, develop contingency solutions, develop emergency response, detail recovery, and restart procedures. And then the fourth stages is the implementation or the implement. Implement risk management and mitigation procedures that include backup, replication, and management of resources. Prepare the disaster recovery sites that can be utilized if a disaster affects the primary data center. And then implement redundancy for every source in a data center to avoid single points of failure. Then the last stages is the train, test, assess, and maintain. Train the employees who are responsible for backup and replication for business critical data on the regular basis or whenever there is a modification in the BC plan. Train employees on emergency response procedure when disasters are declared. Train the recovery team on recovery procedure based on contingency scenarios. Perform damage assessment process and review recovery plans. Assess the performance reports and identify limitations. Update the BC plans and recovery or restart procedures to reflect regular changes within the data center. That's all my report and thank you.